Hi, this is going to be the final demonstration of the full path functionality in Triangle 5. In the previous demonstration, basically I demonstrated that you can use the tool initially to generate flow path and design how the process is going to work. From there, the flow path and any information is then passed on to the automation group, and they use it to do their configuration. And in our case here, it's integrated into DeltaV. Um, the first part of all that could be used on any other system, PLC or whatever. But this part will show that once DeltaV engineers implement the configuration and configure the phases and recipe to mimic the flow path that was given to them, we can download it using Triangle 5, as you can see here, and you will show the configuration. On top of it, you will then we can use the FlowPath functionality to show how the code was generated. For example, we can look at phases and go through the step and generate the flow path from there, which basically it's almost like a full circle where the design part of it is then validated through the configuration, which can be used to show the process engineer what the code is doing. So as you can see, I've downloaded the FHX from DeltaV. We open up the FlowPath functionality. We'll show it here. So now we have the configuration. We can basically, and I've demonstrated in the past quickly, we can see how we can leverage the Triangle 5 tool and the FlowPath functionality and see how it works rather than needing a DeltaV system or simulate it. So we got configuration here, and we will pick here. This is a TFF. So as an engineer, you can select almost any control module. You can go, okay, find me this temperature indicator on the P&ID. It'll bring you to the right P&ID, and you'll highlight the control module that's related to it. So you can now correlate where things are between DeltaV and the P&ID. Actually, it's not only one way. I think I've demonstrated you can pick almost any one of these. You can say, okay, you're looking for this pump. You go say, okay, find this pump in DeltaV. And over here, you see PO2. On top of that, other good feature would be you got a bunch of EMs here, and you can, let's say, the feed, and I probably have demonstrated quickly on the previous demo. You can right click and you can not only find CMs, you can go find EMs. So now you have integrated, so it highlights all these belong to this EM. On top of it, you can see how the EM is configured. You right click and you see open state table. And here it is. Here's the EM. This is the closed state. So in a way, you can try out the EM by going through its states and see how it looks like. So let's try pretend there's something in the vessel, and then you go all close, and I think I've done that before. So feed, how does that feed looks like? Over here it shows the states of each of the individual CMs. You could say identify will show these ones and say run CM state. So you can actively see how the flow path looks like as you go through each state. Line drain, right? So that's useful. On top of it, some additional functionality in here. If, for example, let's look at this EM header drain, and these are a lot of valves, right? Open EM state table. This is how it looks like. If you say identify CMs, it's the entire P&ID is all over the place, right? Here and down here. What you can also do is you can select this, double click on it, and he bring you to that individual state in individual CM. There are other things which I didn't want to go through, but for this demonstration, one of the um, neat feature is to be able to draw the flow path based on the in the phases. So we got a bunch of phases here. We can, for example, go to SI. Let's see how the SIP looks like. All right. This is how SIP phase looks like. Let's put it here. And in my other demos, you can see what it does. It basically look at the phase of the DeltaV. So what we can do is we go through here, and you notice that for the when this is like that, any alias will be replaced by representative control module names. That's what happens here. And then we go through certain TCU, and I think flow path can first be generated by here. And you'll notice that in here it commands this EM to all close. So you can right click on it, you will display all closed state, and then you can say run CM state. Right, so you can go through each one. Right now it's all manual. In the future, maybe you can we can add additional feature where you go through the entire steps and run the entire state. Right now it's one at a time. So display state, run CM to feed all closed. So you see here, you run that, so you command that to all closed and say run CM. So it basically will generate a flow path for you. You can, in theory, what that all that does here is to do all this, right? So let's run it, and this is your initial state. Run CM state. So this is there, and let's go through. Let's go through what's going up. What is heat up? So it's commanding this to SIP. Run basically this generates introduce the SIP into the system. So once you run this, and you notice these are the states. Actually, this P&ID is not correct. It's an NaOH. This is actually a SIP source. So open SIP source, which is basically steam, is represented in this case as yellow. So it's heating up. So it's introducing steam into the vessel, right? And it's going through here. Anything yellow is filled with steam. That's only the first step. So you can go through it, and this is header SIP, and then these are basically your trap valves. Run CM state. So that does that. And then so you just go through it, and I don't want to go through the entire thing, but I'll show up to a certain point and give an idea what it looks like. So here, let's see what this steps looks like. So that opens up these valves, right? And this is the retentate. Okay, run CM state. Those are these valves. Oh, I did that already. Okay, now TMP, I didn't have a state table, but that's basically a TMP, which in terms of flow path, it's not related. Well, it is and it's not, but we can ignore that for now. So this is basically the heat up step, where it's introducing steam into the vessel and around up to this point, right? Then you can go through the next step, which after we prompt heat, and this is heat up time. There's no EM here, right? Basically, so it heats it up to some point and move forward, and then purge. So inlet is sent to purge. So we don't know how that looks like. Let's see. Run CM. Identify. Okay. It opens these up the same. So it's trying to pressurize it. Then it set the air to SIP. Okay, let's see how that looks like. Okay, so basically at this point, when you set this to SIP, it's purging the airline. It's steaming the airline, because the airline goes from here to up here. Before this, I believe these two valves were closed. Now it's purging the airline. So you can see it. So I'll do a few more steps. So it purges the air and pressurize inlet. I think this is the same. And then air to SIP. Okay, that's still the same. And basically SIP, and then this is heat up 2. What does heat up 2 do? You can go like that. Oh, sorry, that's identify. So you notice that heat up 2, it opens up other path. So up here, so you open up these two lines. So you're introducing steam here. It's going up here and into this extra line. And now before it wasn't there, now it's going through here as well. So, and here is actually carrying out the SIP. So SIP for feed, how does that look like? It's the same path, right? And later, it does a two-stage SIP. One stage will be a certain path, and then the rest of it, the next step. It stabilize, and then eventually you will basically, when it's cooling, you put the system in positive pressure by applying air into here, which is stop steam, and I think so it will stop the steam and all that. So before, if you were to look at DeltaV code, there it will be very difficult to imagine how the process looks like. Now there's a way to look through the phases and recipe to generate the flow path from the code and compare it to what we really need. Now I've done this and save it. So you can go at your flow path menu, you can load it. As you can see, I've done several flow path, and for this one there's a SIP. So this is actually how it looks like. So so once you save it, and when you review it with the process engineer, you could say at step 170, this is how it looks like. It's basically set up, which put the system in start state, and then this is the first heat up, right? That's how it looks like, and I've shown that before, right? This is actually first stage of the heat up, and then it tries to not pressurize, but it does the steaming part. This is the second flow path, right, in here, and then heat up 2. Basically, that's pressurize and heat up is the same. And then you'll stabilize. It carries out SIP. Make sure all the temperatures up to a certain dwell time and for a certain duration. Then this step 310, it shuts off the SIP line, which I believe is right, this line, this yellow line. And you'll cool down. This is how it looks like. Cool down. Cool down is basically introduce air to with a certain pressure, cooling it down, and from there it leaves the system in basically positive pressure, and it quits. So you can actually be pretty efficient in the whole process using this tool, where the process engineer, rather than um, drawing the flow path manually and usually a one-time step where to update it, to change it is very difficult, time consuming. Using the tool here, you can update and change your flow path easily and update it, and from there they would usually pass it on to the automation engineer, which then with the flow path it will be useful, but sometimes it's through description, it's difficult to visualize sometimes without the flow path. So the automation engineer, once generate the EMs and so forth, is usually sent back to the process engineer, and they, instead of looking through documents, they can use the tool to visualize what the code is doing, which currently we have a simulation system, and to set up the simulation to demonstrate it, it works. It's more, probably more time consuming, and to when you do a flow path like this, you can jump around, right? You can jump around. Oh, let me look at the SIP step. How does it look like? Whereas if you do a demonstration, you move the code up and down, different changes. It's a lot more cumbersome. Plus, visually seeing a flow path is much easier than looking at a graphic and try to visualize. Okay, certain valves are open. You should go through this or through that. And when you get a complicated system like a TFF here, trying to visualize this where things are happening in the graphic without actually showing the flow path, it's, unless you know the system very well, it is kind of difficult. So hopefully what I've demonstrated here in the several demos to convey how the entire process can be actually easier, and it all focus on the P&ID, which is a common master document used by everybody, and that's a central source for everybody to look at, to visualize, and to collaborate on what needs to be done, and trying to get it right the first time. All right, thank you for listening, and talk to you later. Bye.